Okay, in this video what I'm going to do is introduce the concept of a precipitation reaction. And in previous videos I introduced the general classes of reactions, and precipitation reactions fall under the general class of what are called double replacement reactions. And the reaction that I'm going to start out with, which is really common in laboratory settings, is the reaction between barium chloride and sodium sulfate that produces barium sulfate and sodium chloride. Now, precipitation reactions are special for a couple of reasons. The first is, like I said a minute ago, is that this is a double replacement reaction. So what's going to happen here is that the barium is going to switch places with the sodium. So the barium is going to actually mate up with the sulfate, and the chlorides that are here are going to bind, or they're going to mate up with the sodiums. So there's going to be a switch. The respective cations in each of these ionic compounds is going to switch places. That's number one. Number two, which is perhaps more important, is that these kinds of reactions are used very often in analytical chemistry to identify the presence of either an anion, like the sulfate here, or the cation, as in the barium. So let's back up for a second and go more to the basics. So, like I said, a precipitation reaction is special, and one of the things that you're going to notice about it, first off, is that it involves the combination of two ionic compounds that are both in solution. Let me switch colors here. Or that are both in solution, noticing that both compounds are followed by the designation aqueous, which means that we're taking essentially two solutions, each solution containing an ionic compound that is fully dissolved. We're mixing those two solutions together, and the outcome is that we form a solid as one of the primary products. And the other compound that is formed remains in solution. So this product here remains in solution. All right, so if I was to draw a picture of this reaction in a beaker, all right, at the bottom of the beaker is going to be a pile of sludge that is the barium sulfate. And while I can't accurately draw the color of it because I'm using a white background here, I'll just indicate that it is a white solid. It is a white solid. All right, and the important thing to realize by the viewer is that the sodium chloride remains in solution. So the sodium ions and the chloride ions are floating around here in the solution, and sitting at the bottom of the beaker is this white solid, which is the barium sulfate. So if we the importance of these reactions is because an analytical chemist can use them to identify things that are in solution. So say that we had a solution that contained a sulfate in it. All right, I'll draw a picture of that up here. So we have a solution, and this analytical chemist suspects that in this solution there's sulfate ion, and they want to do something in order to potentially identify that fact. Then that chemist can add, for example, a solution of barium chloride or barium nitrate, for example, to this, and if a white solid appears that essentially settles to the bottom of the beaker, that's a first indication that this solution potentially contains sulfate. So these are very important reactions for being able to identify the presence of particular cations and anions. Now, going back to what I talked about at the beginning of the video, technically speaking, a precipitation reaction involves the combination of two solutions that contain ionic compounds. So oftentimes you're going to be asked to write what's called a net ionic equation that shows the formation of the solid that results from this reaction. And in order to do that, there is a process here. The first is recognizing that the two compounds that are being combined here are ionic solutions. And what that means is that the two formulas, in the way that they're written, don't accurately represent how these ions actually exist in solution. So one of the rules that the viewer needs to understand about ionic compounds is that, and I'm going to write this out, is that if an ionic compound is dissolved in water, then the compound is fully ionized. So what that means is that the two compounds, the way they're represented here, are not exactly accurate. And in terms of a precipitation equation, what we're going to want to do is rewrite this to show that the compounds are actually ionized. So what I'm going to do first is I'm going to write what's called the full Ionic equation, or the complete Ionic equation. Alright, so to do that, what I'm going to do is show each of the compounds fully ionized, like this, noting that the barium is out of group 2A, so it carries a charge of +2, and then notice that there's two Cl's in the formula, and Cl chloride is out of group 7A, so it carries a charge of -1. And then this is going to be added to the fully ionized version of sodium sulfate, which is written this way. Alright, and then we have our reaction arrow, and on the right side we show the solid properly written. It's not separated into ions because, remember, see, it's actually a solid, and in a solid the ionic compound is going to, the cation and the anions are combined. And then on this side, though, we need to recognize the fact that the sodium chloride is in fact fully ionized. So this would be the complete Ionic equation. Now, in the last part of this, what we're going to do is write the net ionic. And in the net ionic equation, the only ions that are going to be shown will be the ones that are responsible for producing the solid. So what we're going to do is go through the complete Ionic, and we're going to cancel out the ions that appear on both sides of the equation. All right, and notice that the chlorides are on both sides of the equation, and the sodiums appear on both sides of the equation. So we go through and we're going to cancel these, just like in a regular math problem. All right, and the ions that appear on both sides of this arrow have a special name. I'll put that down here. These are called the spectator ions. All right, and I'll list them. It's the sodium and the chloride. And these are not involved in the reaction, and I'm just going to abbreviate reaction as RXN. So when we go to write the net ionic, all right, it's only going to involve the ions that are involved in producing the solid. Oops. Is shown here. Okay, and like I said at the beginning of the video, to finish up, the purpose of these in the laboratory is because they can be used to identify, at least initially, the presence of a cation or an anion. So in the case of this precipitation reaction, the addition of barium ion can be used to identify the presence of sulfate. And by the same token, the addition of sulfate to an unknown solution can be used to identify the barium.